A factory makes frozen hamburger patties. The weight of each patty is at least 3.5 ounce and at most 4.3 ounce. Write an absolute value inequality and a compound inequality for weight of a patty. The compound inequality is the easier one to say here. If I say x is the weight of a patty in ounce, then this above here is saying that x is at least 3.5 and at most 4.3. Now this inequality is what we call the compound inequality. Because it's really two inequalities written at once. See, this is equivalent to saying that x is greater or equal to 3.5 and x is lesser or equals to 4.3. And therefore, this is these two are the same, and you have more than one inequality. So that's why it's called compound inequality. Now, what about the absolute value inequality? Well, the absolute value inequality, you first have to know the form. The form looks like x minus a number less than some value b. Okay. And here, because our compound inequality had the equal sign in there, we should also have that. And for these type of inequalities, I had in a previous video an analogy of what's going on. It's like you have a dog and a dog owner. The dog owner is at location A, and X is the location of the dog. So X is somewhere here, and then there's a leash. The leash length is at most B, so even if the dog tries to go further than B, he's stuck. So this X can at most be, let me erase X. Right. So the X can go at most A plus B, and if the dog tried to go to the left, at least it should be at A minus B. So that's the generic solution. A minus B to A plus B is the solution to such an inequality. Our situation is a little different. See, this compound inequality that we found was saying that the solution is between 3.5 to 4.3. Our X is between here and there. And since the dog owner is right at the center, to figure out the center, we have to calculate the center. How do you get the center? Center is equal to the average of two values, right? So you take 3.5, 4.3, divide by 2, and 7.8 divided by 2, that's equal to 3.9. So 3.9 is the center. That's going to be our A in this inequality. So now all we need to do is to figure out what goes in the right side. Well, that's the length from the owner to the farthest point. So you have to figure out what this length is, which is 4.3 minus 3.9 is 0.4, right? So 0.4 is this length, and likewise, if you subtract 0.4, you're gonna get to 3.5. Because 3.9 is the center, is the midpoint. If this length is 0.4, this length should also be 0.4. So we know that the absolute value inequality will be like this. So this is your absolute value inequality. Okay, so these two things are the answers to the question. Let me give you another example. A factory makes 60-inch long USB cables. The cables are allowed to vary as much as 0.3 inches. Write an absolute value inequality and a compound inequality for a length of a cable. So here, the word problem itself first gives you the absolute value inequality. That's the one that's directly given. So think about it this way. If I say x as the length of a cable, it says that the difference between x and 60 is at most 0.3 inches. Now, if that's true, then what is the compound inequality? Notice that this is already in the form of absolute value inequality. This is the absolute value inequality. Right? And the compound inequality would be saying I mean, again, if you draw the graph, you're here at 60, and then there's a dog leash that's 0.3 long, so 60 plus 0.3, that's 60.3. And what's 60 minus 0.3? That's 7, 9, 59.7, so it'll be at 59.7. So that your length of the cable is somewhere between here. So the compound inequality would be x less or equal to 60.3 and at least 59.7. So these two are the answers.